Okay, in this video I'm going to go over Chapter 4, Algebra 2 practice test, and I'll probably be doing two parts on the videos just so that I can have enough time for each one. So let's go over number 1 here. The first thing we need to do is set these equal to each other. We're really using substitution here. So after you set them equal to each other, we want to go ahead and add 5 to both sides. And then we're going to rewrite. So we're going to have 2x plus 3 squared equals 14x plus 12. So what we want to do here is we want to get rid of everything outside. The next thing is we're going to divide by 2, and then we're going to end up getting x plus 3 squared equals 7x plus 6. Hold on. Oh, this was supposed to be 22 plus 11. So now the next thing I want to do is I want to go ahead and start applying that exponent of 2, that square. Now the reason is because I don't want to square root both sides. I want to square this one so that I get a polynomial. So I'm going to get x squared plus 6x plus 9 equals 7x plus 11. So now I'm going to move everything to one side. So I'm going to subtract 7x from both sides. And then I'm going to subtract 11 from both sides. And the reason I want to do that is because I want to end up with 0 on the right side. And that's eventually so that I can use the zero product property. So the next thing is to factor. So if I factor this, I'm going to end up getting x minus 2 times x plus 1. Now you guys may need to use the area model to factor. From here we can see that we're going to end up getting, and let me get an extra sheet of paper here. You guys may need an extra sheet of paper just to continue showing the work. Sometimes you won't have enough room. Alright, so on this extra sheet of paper I'm just going to continue with number 1. So with number 1 I solve, so I'm going to get x minus 2 equals 0, x plus 1 equals 0. This is the reason why you guys want to set the equation equal to 0, is because then you can use the zero product property, which is what I just did here. So I'm going to get x equals 2 and x equals negative 1. So those are my two answers, but now I need to plug them back into my equations and get y. It doesn't matter which one you plug it into, just choose one. So I'm going to plug in 2 into the bottom equation. So y equals 14 times 2 plus 17. I end up getting 28 plus 17, which is equal to 45. So 30, 45. For this one, I'm going to plug in negative 1 into the same equation. I could have done it to the other one, but I'm just going to plug it into the same one. And I end up getting negative 14 plus 17. That's going to be 3. So now I can see that when x is 2, y is 45, so one of my intersection points is 2, 45. The other one is negative 1, 3. Alright, so there are your solutions to the system of equations. So when you guys have a system of equations with both the y and the x, you actually need to find both the x and the y, which end up being the coordinates. So this is my solution for number 1. Now let's go on to number 2. So number 2, you have to solve the equation for x and then check for any extraneous solutions. So the first thing I want to do is isolate this square root. So I'm going to subtract 7, and I'm going to get negative 15. Then I'm going to divide by negative 3, and I'm going to be left with 2x minus 5, square root of that, and I get 5. Now we have the square root function isolated. It'll just make it easier so that when you guys square, you don't have to worry about anything outside of it. So I'm going to square now. I'm going to get 2x minus 5 equals 25. And from here you can just continue. Let me go ahead and continue over here. So I'm going to get 2x, I add 5 to both sides. That's going to be 2x equals 30. So x equals 15. Now we want to check, make sure that's not an extraneous solution, because whenever you guys square both sides of the equation, you're creating possible solutions that are not really solutions. So over here I'm going to check, and I'm going to plug it back into the original equation. So it would be negative 3 times the square root of 2 times 15 plus minus 5 plus 7 equals negative 8. So I'm going to simplify now. So 2 times 15, that's 30, minus 5 plus 7 equals negative 8. 30 minus 5 is 25. And then the square root of that is 5, so it's negative 3 times 5 plus 7 equals negative 8. So that's negative 15 plus 7, that's going to leave me with negative 8, which is equal to negative 8. So now I see that this is actually a solution. It's not extraneous because it worked. So there's my solution for number 2. It's x equals 15. Alright, let's move on to number 3. So number 3, you guys have this equation here, and they're asking you to solve, so we want to find out what x is. Now the first thing I want to do is I want to isolate the absolute value. Same thing as what we did over here. We isolated the square root function, isolate the absolute value. So add 6 to both sides. We get 21. To undo the absolute value, we write two equations. One of them equal to 21, the other one equal to negative 21. So now notice that I don't have to write my absolute value anymore. And solve each one. This is going to be 26, so x equals 13. This one's going to be negative 16. So x equals negative 8. So x equals 13 or x equals negative 8. So plugging in either this one or this one into the equation will make it work. So those are your solutions for number 3. Let's go on to number 4. For number 4, same idea here. So we want to start by getting rid of this outside. So we're going to add 7 to both sides here. We want to isolate this whole group. So we're going to end up with 4x plus 2 over 2 equals 15. I don't need the parentheses anymore because there's nothing being added or multiplied outside of this whole group. Next thing I can do is I can multiply both sides by 2, and that'll cause for these 2's to cancel. So we'll just be left with 4x plus 2 equals 30. At this point, I subtract 2 from both sides, get 28, and x equals 7. And that's it. So there's our answer for this one. Alright, let's go on to number 5. So for number 5, they ask you to graph the solutions for this inequality right here. So the first thing we need to do is we need to write our x and y axis. Now I want to graph each of these. So think of this one as one equation. So y equals 2x squared minus 5x. Think of this one as another equation, y equals 12. So we're going to graph both of them. So when you graph y equals 12, the way to remember is that this is pretty much telling you that every y value is going to be 12, no matter what. 12, 12, 12, 12. Whether x is negative 1, or 0, or 1, or 2. So when you start plotting it, let's say we go by 2's. 6, 8, 10, 12. So at 0 we're going to be at 12, at 1 we're going to be at 12, at negative 1, at 2. So if we continue, we get this line right here. So that's the line y equals 12. Now to graph this one, we can just factor out x. So I can say y equals x times 2x minus 5, and then I can plug in 0 into the y so that I can find out my x-intercepts. And so x is equal to 0, and the other one, 2x is minus 5, is equal to 0. So when I solve this one, it's going to be 2x equals 5, so x equals 2.5. So now I know that my x-intercepts are at 0 and 2.5, which is going to be right here. Now my y-intercept, well, there's the y-intercept right there. So to find out where these graphs cross, I can just set these equal to each other. So I'm going to have 2x squared minus 5x equals 12. And I'm going to find out where these graphs cross each other. I'm going to continue this on the next video because I've ran out of time, so there will be a second part to this video.